Welcome to Bite-Sized Chemistry. Today we're going to be talking about endothermic versus exothermic reactions and this concept of delta H. So in the last video, we talked about how we can look at a graph and based on whether the products are higher than the reactants, we can determine whether a reaction is exothermic or endothermic. In this video, we're going to talk about what those terms mean. So when we talk about something being exothermic, the characteristics we tend to see are the following. So exothermic reactions tend to feel hot. Okay. So if we're thinking about like adding yeast and water into a bag, the bag will actually warm up and get hot. Okay. And that's indicative of an exothermic reaction. The second thing we'll notice is that energy is released, which means when we look at a graph, the products have less energy or lower than the reactants. And when looking at a graph or looking at an equation, we'll also notice that exothermic reactions have a delta H that is negative, right? And all delta H is the measurement of heat energy. So this is heat energy. And if the value is negative, it means heat has been given off. So negative heat is released. On the flip side, endothermic reactions have the following characteristics. They tend to feel cold to the touch. So vinegar and baking soda will feel cold if you mix them together. Energy is absorbed. The heat energy is taken from the surroundings and put into the system or into the reaction. The products have more energy than the reactants. And finally, the delta H, or the change in heat energy, will be positive. All right. And that positive sign indicates that we put heat into the system or energy into the system. Okay. Now that we kind of have an overview of what endothermic and exothermic are, let's look at some practice problems or some ways you can be asked to test your knowledge, right? So the first one here says, let's pick green. During a soccer game, a player twists their ankle. The coach grabs an instant cold pack from the first aid kit and activates it by squeezing the inner pouch, which starts a chemical reaction. The temperature of the pack quickly drops and feels very cold to the touch. Based on this information, is the chemical reaction inside the cold pack endothermic or exothermic? All right, so if I just sit there and think about it, exothermic, the word exo sounds like exit, so that means heat is exiting, so my object should feel hot. Versus endothermic, so let's write that down. So exo equals exit, which means it should feel hot because the energy is exiting the system. Endo, we want to think of enter because the heat is entering the system, making it feel cold to the touch. Okay. So based off of this, if it feels cold to the touch, then I know that the reaction is endothermic, meaning that heat is absorbed. So heat is absorbed, which means that it feels cool or cold. All right, let's look at one more. So this one says, a student burns a small piece of magnesium ribbon in the lab. As the metal burns, it gives off a bright white light and produces a lot of heat. The reaction also has a delta H of negative 601.6 kilojoules per mole. Is the combustion just means to set it on fire, of magnesium an endothermic or exothermic reaction? Well, there are two key pieces of information that I see here. The first one is that it gives off a lot of heat. And the second one is that it has a delta H that is negative. Right. Now, if I kind of look at my little mnemonic, exo equals exit, which means it's hot. Endo equals enter, which means it's cold. Okay, so just off of those observations alone, if it feels hot, I know heat exited it, which means it should be an exothermic reaction. But if I didn't have that information, I could also look at the delta H and realize that if the delta H is negative, then that means that the heat was released from the system, meaning it's exothermic. So it's exothermic reaction for two reasons. It feels hot and the delta H is negative. All right, that's it for today. We'll catch you at the next episode of Bite Size Chemistry. See you later.